Okay, tell you what, just hold it tight, give me your hand, and you let go, touch Ian's nose, and again, yeah, round and round and round, now watch it.
Who's is that?
Wow.
Yeah. Who's is that?
Hello everybody! This is a little bit different. This is not a bubble show, but this is about science. And yeah, but it's not like science in school. This is like science you can do yourself. Okay. Now, shall we start with the exploding custard?
Yeah.
You might think exploding custard is some kind of silly joke, but it's jolly well not. It's a very scary thing. I'm going to show you a very, very scary photograph. Are you ready? This is a photograph of the factory where this kind of custard powder used to be made. Okay? And it was destroyed. I'm sorry people over here, you can't see it. We had a last minute rearrangement. But the factory was blown up by an explosion. And guess what exploded in the custard factory? Custard! It did. And who would like me to show you how it happened? Yeah. Do the people at the very front want me to show you how? Yeah. Well, let's see. Custard powder is a very, very fine kind of flour called corn flour. Okay? Very, very fine kind of flour. And it's got vanilla and flavouring and yellow food colouring added to it, but otherwise it is just corn flour. Shall we set fire to some? Okay, here we go. Okay, take cover. Get ready. And we put the custard powder in the flame. Are you ready for this? And hey, nothing much has happened yet. It's gone black around the edges. It's burnt round the edges. And you've learnt enough science in school to understand that before things burn, they need air. Okay? And the air can only get round the edges of this massive powder. So let's try sprinkling it through the flame in little bits. Maybe we'll have more edges. Can you see it burning in the flame? Yeah? Because each tiny grain is so small, the air can get all the way around it and it burns in a flash. Poof, like that. How about if we make a whole load of grains all burn at the same time? Yeah? Yeah. So if I fill the end of this piece of drinking straw with custard powder and blow it through the flame, okay, these boys over here will get the best view because the burning custard powder will be travelling in their direction. Okay? Are we ready? Okay. This is where you all get your money back because that was actually pretty pathetic. Okay? We can make a much bigger custard powder explosion than that, but that was a small version of the explosion that destroyed the factory. The air in the factory filled with a great cloud of custard powder dust and was lit by a spark, and the whole factory blew up. The roof came up, the walls came out, it was destroyed. So, we can put a lot more custard powder in here, can't we? Yeah. Into this funnel. That's when the funnel begins. I've got an air pump. Now that sound you heard then was the sound of young minds working, because you're thinking, when I go like that and blow the air through the custard powder will go up towards the ceiling and catch fire. Do you want to see me do that? Yeah! Or do you really want to see me do that? Yeah! And that's why we're going to do it at the end. So, we're talking about science today, and the great thing about science is that children are better at science than grown-ups. This is really good news. I have a theory about grown-ups. My theory is that generally speaking, the older you get, the more boring you get. Does anyone agree with my theory? Yeah? Okay, I think some people here agree with me. I've got to prove it. So we're going to try and prove my theory scientifically this morning. Now here's a piece of evidence for you. How many people have been, remember, standing in the bathroom, washing their hands, and the grown-up standing behind said, "Stop messing about with the water, just wash your hands." Put your hand up if you've heard a grown-up say those words. Hands up. I've asked that question all over the world, and it happens. Okay, that's my first evidence. So, let's have a look at some water. Let's put some water on here and we'll see it on the screen. I can hear people saying, "Wow."
Wow.
Okay, I can. Not many grown-ups, mostly children, but that's part of the problem. But even boring grown-ups sometimes remember lying in the bath, dabbling their finger on the surface of the water, watching the shadows of the ripples on the bottom of the bath. Okay? How many people have done that in the bath? Okay, why is it only the children that got their hands up? Okay? See, adults get more boring, they don't experiment so much. Now, there's something else that children are better at than grown-ups. They're better at noticing things. Grown-ups are rubbish at noticing things, aren't they? So let's show the grown-ups how good you are at noticing things. This is called making observations when we're doing science. So I'm going to put some Rice Krispies into the water, and you're going to tell me if you notice anything interesting happening, okay? Away we go. Okay. What can you see? They're scrumpling up, yeah? What else? Come on, shout out. What can you see? Yeah, yeah.
They're grouping together.
Grouping together, they are. They're going snap, crackle and pop, it says in the packet as the air bubbles come out. Isn't it interesting that they're joining together? Now this is interesting because it's not mentioned in any science textbooks. How many people here have noticed their breakfast cereal attracting each other when they're floating in the milk? Who's noticed this before and thought about it? Please put your hands up now. Who's noticed it before? Now I can see a lot of children with their hands up, and I can only see one grown-up with a hand up, okay? That's more evidence that grown-ups are more boring and not such good scientists. Right. Would you like me to explain why they do that? It'll take about an hour. Would you like me to do some more experiments? Right, so we're not going to stand here explaining everything today. What I'm here for today is to make you think and to make you see how good you are at science. Okay. Has anyone ever tried putting washing up liquid on their Rice Krispies? No? Oh, right. Okay, let's try it. So let's dip the end of a matchstick into the washing up liquid and put some on the surface of the water. Let's say over here. Anyone like to predict what's going to happen? Okay, rainbows, explosions. Let's find out. Hold your breath. Oh, they moved away. Okay, so we've made an interesting observation. We've noticed that small floating objects move away from washing up liquid. Sometimes when somebody makes a new observation like that, some clever inventor comes along and makes an invention from that idea that makes him stinking rich. Shall we try and invent something together today and get stinking rich? Okay, if we're successful, you've got to share the money with me. If you go away and make a lot of money out of this, my website is on the screen. Because I've actually got an idea that we could try. Let's put some more water in there. Look at the lovely patterns. Look at that. Do you watch raindrops on a wet window? Grown-ups don't, but children do. Fascinating. So, here's the idea I've got for an invention. I want you to close your eyes. Imagine that you're out at sea in a small boat and you're drifting out to sea because you've got no motor, no sail, no oars, and you've been blown out to sea. What are you going to do? All you've got in your boat is a bottle of washing up liquid. Open your eyes. Any ideas? What could we do? Yes?
Pour it into the sea.
put the washing up liquid into the sea. Right, scientist here's got a good idea. So if we do that, would you put it in the water in front of the boat or behind the boat? Behind the boat. So the boat might move away from it. Now if this works, we're going to get stinking rich. Because boats won't need engines anymore. Who thinks it's going to work? Who thinks it's not going to work? Shall we try? Let's try, yes. So here, I've got some very, very tiny boats made of cardboard, okay? They're so tiny you can't see them. Let's put one in the water. There we are. That's our little boat drifting out to sea, helplessly. Let's put, we're using two boats to make sure we're doing a fair test. So this other boat is going to have a little bit of washing up liquid on the back. Let's see if that makes a difference. Are you all thinking what you're going to spend the money on if this works? Yeah, okay. Are you ready? Hold your breath. Yes!
Whoa!
Got a slight steering down. Oh my gosh. Okay. It's stopped. Who's going to try that experiment at home afterwards? I want you to try lots of these experiments at home. Try and remember. Okay, good. So I'm not saying any more about that. You can experiment at home and think about maybe why that happened. Maybe you'll find out one day. Maybe you won't. If you're boring, you won't find out. If you're not boring, you will find out. Who'd like to help me with an experiment? Okay, you put your hand up first. Do you want to come out? Would you just like to stand here? Okay, good. And face me. And here, I've got a bottle, empty pop bottle, full of water, and floating in it, I've got a sachet of sauce. You can use any kind of sauce that floats. This happens to be brown sauce, okay? Now, when I put it in the water, it floated too high, because I wanted it only just floating. So if you look closely at the bottle, can you see there's a yellow paper clip on that? A heavy metal paper clip, making it heavier. I kept adding paper clips till it sank, then I took one off, and now it's only just floating. And the experiment is, I'm going to ask my young friend to squeeze the top of the bottle with both her hands, okay? And what's going to happen? Any ideas? Because when she squeezes, she'll increase the pressure in the water, she'll squeeze the little air bubbles in the sauce smaller. Let's see what happens. Squeeze the top of the bottle really hard. Wow! Now she lets go, it comes up again. Right, don't clap. I'll tell you what, clap at the end, because I've got so many more things to show you and I'm trying to move fast. Let's try another experiment. This time, we're going to squeeze the bottom of the bottle. Now then, I want you to vote on what's going to happen. I want you to put up your hand if you think it will sink if she squeezes the bottom of the bottle. Put up your hand if you think it will sink. Grown-ups don't like being wrong, so I'm not putting the hand up. Who thinks it will not, sorry, who thinks it will sink? Who thinks it will sink? Sorry, who thinks it will not sink? Who thinks it will not sink? Okay. Who was too nervous to put the hand up? Oh, never mind. Let's find out. Squeeze the bottom of the bottle.
Oh.
It does sink. Okay. Okay, that's interesting. You can carry on experimenting with that for a minute while I just talk about that. It doesn't matter which direction you apply the force, you still increase the pressure. We can demonstrate that with this apparatus here. So, if I apply the force in this direction, well, I mean, presumably that means that the water will go that way. Is that right? Which way will it go? Oh, it goes that way. Oh, yeah. Anyone else not understand about pressure? Okay, good. Let's move on. We can do great things with pressure. Look, I can put this table tennis ball in my hand. Let's see if I can do this. This doesn't always work.
That's not funny.
Table tennis ball, I'm going to increase the pressure underneath it. Yes. Okay, let's try another experiment. Could you bring that forward and put it on the table for me, please? Let's turn the bottle on its side. Look, turn it on its side. Now my friend's going to squeeze the middle of the bottle. If she squeezes the middle of the bottle, will it move across to this end?
Mummy.
Who thinks it will not move across? Who thinks it will move across? Oh. Who thinks it, come on, let's all vote, come on. Who thinks it will not move across? Who thinks it will move across? Okay, most of you think it will move across. Who thinks it won't? Now, most people disagree with you. Does that mean you must be wrong? Not necessarily. Science is about thinking for yourself, isn't it? Squeeze the middle. Squeeze hard. Squeeze as hard as you can. Yeah, it's not moving across. Okay. Wonderful. Are you going to make one of these at home? Yeah? Okay. Wonderful. Give my friend a clap. Go and sit down. Thank you very much. Some of us were playing with this earlier. How many people have heard that the water always goes anti-clockwise round the plug hole? Yeah? Who's heard that? How many people have tried it for themselves? Yeah? Good. We've got some scientists here. Did anyone try it for themselves and think, hang on, it doesn't seem to work. It seems to go either way. How many people? Not many. So you just believed what you read, okay? It's not true. This is something else about science. Not everything that you read in books, thanks very much. Not everything that you read in books is true. Okay? It's about thinking for yourself and experimenting. Good. Okay. Let's try another experiment with a bottle. You've learnt about solids, liquids and gases. The bottle is solid, the water is a liquid, and the air inside the bottle is a mixture of gases. Okay. What gases have we got? Nitrogen, carbon dioxide, oxygen. There's another gas beginning with W, everyone always forgets about. Gas beginning with W. Yes, water can be a gas, water vapour, that's right. Okay, so we've got lots of water vapour in there. When water vapour, thank you darling, when water vapour changes back quickly to liquid water, it makes a cloud. Should we try and make a cloud in the bottle? Okay, I'm going to increase the pressure and suddenly release the pressure. Tell me if you see a cloud. Hey, didn't work. I'm going to try something else, because in the sky where real clouds form, we have tiny, tiny particles of solid matter, solid dust particles and other things, and they help clouds form. So if I drop a burning match in there, I'm going to add a tiny bit of smoke to the mixture of gases. Okay? Let's see if that makes a difference. Okay, so I'm going to increase the pressure. Tell me if you see a cloud when I release the pressure. You're all watching. Whoa! Increase the pressure and it's done again. Okay? So what that cloud was made of was microscopic drops of liquid water. And as soon as I increase the pressure, they go back to water vapour again. How many people have noticed that before when they're drinking a fizzy drink? You take the top off and it goes and releases the pressure and you've seen the cloud. How many people have seen that before? Very, very few adults and a lot of children. Well done kids, you're better at noticing things. You're better scientists. That's really good. Now, I'm going to show you a party trick you can do with an empty plastic bottle and a candle. When I tap the side of this bottle, I actually make a little smoke ring. But you can't see the smoke ring, but it's got a lot of energy. Actually, there's a bit of a draft in here now. This might not work. I'm trying to blow out the candle flame. Okay, you can see the flame moving, but I'm not blowing it out. I can't aim. I need to see the smoke rings. Let's make some smoke. Okay, so I can, if I blow in the side of my e-cigarette, I've got smoke coming out. No fire, no fire, it's okay. Right, let's see if we can make a smoke ring. Can you see that? I know the lighting's difficult sometimes. Can you see the smoke rings? Okay, nice. Try this at home. Let's see if I can blow the candle out now. There's a lot of draft there. Let's try moving the candle over here. There's still a lot of a draft. Hey! Right. Right, now would you like to see a bigger smoke ring? Now this is a toy called an airzuka. Just Google airzuka and you can buy one for about £10. And it's a really, really good toy. And it makes giant smoke rings. So, do you want to see a giant smoke ring? We couldn't see it, could we? We actually need a target. And this little girl here, would you mind going to stand over there, please? You don't want to be the target, okay? Just go and stand over there when I'm pointing. Stop, that's it, that's fine. Okay? A nice long range shot. Let's see if we can make this little girl's hair move. Watch. Whoa, that was good. Thank you. Go and sit down. Very good. You can make lots of people's hair move. There we go. Now, wouldn't it be nice to be able to see the smoke ring? So let's put some smoke in it. That's good. Let's try now. So let's shoot at that light. Shall we? Let's do that. That's good. A bit more smoke. Okay. This time I'm going to aim at you. Right, who shall I aim at first? Okay, nice. So, get straight on the internet when you get home, buy yourself an airzuka. Absolutely wonderful. Now let's go back to this business about grown-ups not liking to be wrong and not liking to put their hands up. Okay? So we're going to do an experiment now, which is a competition between the children and the grown-ups. Okay? So you've got to vote for the outcome of this experiment, and we'll see who are the better scientists, the children or the grown-ups. I'm going to put the toilet roll here, and I'm going to pull the end. I'm just going to pull the end of the paper this way, and you're going to tell me what the toilet roll is going to do. There are three possibilities. When I pull the end this way, the toilet roll could come this way, or it could stay where it is and just go round and round in one place, or it could go that way. Now, you've never learnt that in school, unless you've experimented in the toilet, which I recommend anyway. You won't know, okay? So, put your hand up if you think the toilet roll will stay there and just go round and round without going in either direction. You've got to vote. Everyone's got to vote, grown-ups as well, or you'll lose. Who thinks it's just going to stay there and rotate? Okay. Now, lots of people disagree with you. That doesn't mean you're wrong, does it? Put up your hand if you think the toilet roll will come this way. Who thinks it will come this way? Okay? Okay, hands down. Put up your hand if you think the toilet roll will go that way. Okay, maybe I won't show you. Do you really want to know? Yeah! And that feeling of really wanting to know is what makes science happen. That's what science is all about. Good, I'm glad you want to know. Shall we find out? Yeah. Hold your breath. It came this way. How many children got that right? Lots. How many grown-ups got that right? 3. Right. Children won. Okay, very good. Now the grown-ups are thinking, well, he didn't pull it properly. I'll do it again if you like. How would you like me to pull it this time? Harder, harder, okay. It's cheap toilet paper. Still comes this way. Any more ways you'd like me to pull it? Pull it down, yeah? Still comes this way. Pull it up. Ah, scientist over there wants me to pull it upwards. This time vote with your finger. Will it go this way or that way? Point, let me see. Someone thinks it's going up to the ceiling. Fair enough. Okay, hold your breath. Yeah. Have you ever cheered a toilet roll before? Okay, this kind of science enriches your life. Seriously. Good. Good. What's happening next? Oh, yes. let's do another experiment where we vote what's going to happen. Everything here is so simple. You can make all this stuff yourself or find it in the kitchen. I've made this balance myself. Very simple. There's a pin through there, a lump of plasticine for a weight, half a bottle like a bucket, bit of coloured water in there so you can see it. If I just touch the bucket, it tips the balance. But the thing is, I'm not going to touch the bucket. What I'm going to do is dip my finger into the water without touching the bucket. What will happen? Isn't that interesting? Not thought about this before. The three possibilities. The bucket could stay still, it could go down, or it could go up. Okay? Who thinks the bucket will stay still and not move? Who thinks the bucket will go down? Who thinks the bucket will go up? A lot of you didn't vote. A lot of you didn't vote, okay? Because you didn't know, did you? Why don't you just guess? Let's do it again. Just guess. Who thinks the bucket will stay still? Come on. Who thinks the bucket will go down? Who thinks the bucket will go up? Almost exactly 1/3 of you voted for each option. Interesting. Shall I do it? Maybe I won't show you. You want to know? Yeah. Okay. Hold your breath. It goes down. Isn't that interesting? Isn't that interesting? Let's try dipping a spoon in. Will it go down if I dip a spoon in? Who thinks it will? Who thinks it won't? Let's try. It doesn't seem to be moving. But hang on, watch the plasticine. It just went down a tiny, tiny bit. A tiny bit. Is that because the spoon is made of metal? Or is it because the spoon's very thin? I'm not going to tell you. If I explain everything, you stop thinking. And that's not the idea. Let's swap this over. We're going to try another experiment. We're going to... What are we going to do? We're going to hang the spoon on the end this time and try a different experiment. I can balance it by sliding the plasticine. Okay, it's balanced. The experiment this time is to bring the water up over the spoon. Okay, there are three possibilities. It may not move, it may go down, or it may go up. Now this time, it's interesting. This time, I know what you're going to say. Because I've done this so many times. My job is to communicate science to people. My job is to design interactive exhibits for science museums around the world. And I learn a lot from doing this show about how you see things. Very interesting. So I know that you're going to get the answer right this time. Not all of you, but most of you. So, let's vote. When I bring the water up over the spoon, who thinks the spoon will not move? Hands up. Who thinks the spoon will go down? Who thinks the spoon will go up? Most of you. Hold your breath. And I was right. Nice one. Okay, now when you go home tonight, rush out to the shops. The shops are going to sell out of red cabbages, so be quick. Everyone's going to be buying a red cabbage tonight, because this experiment is one of the best ones to try at home. A red cabbage. Break off some leaves from your red cabbage, drop them into a jug, and with a grown-up helping you, pour on some boiling water. And leave it to stand. It's like making a pot of tea. And it changes colour. Just like tea changes colour when it's brewing. But the interesting thing is, it's not really red, is it? Yeah, it's like a pinky purple, isn't it? Okay, whoops, wrong glass. Right. Now, would you like me to show you how to make that go bright red? Yes? Okay. All you need is some vinegar. So you've got cabbage water and vinegar. Okay? Let's see if it's already quite reddish, but there we are, look at that. Who's going to try that at home? You could give that to your parents to drink, couldn't you? Cabbage water and vinegar. Yeah. Looks delicious. Okay, let's do it again. Now, would you like me to show you how to make it go blue? Wow. It's actually quite easy. You need something which has the opposite effect to an acid. And in this case, it's bicarbonate of soda. Okay? Sodium bicarbonate. You can buy this in every supermarket, bicarbonate of soda. It's a salty tasting, safe chemical, has the opposite effect to an acid. Okay, let me come and stand over here. And let's put some in. And you all see, let's see what happens.
See that?
Oh my goodness. Who likes messy experiments? Yeah, I thought so. Okay, well that was kind of interesting. Now several things happened then. Oh, the colour hasn't changed. Let's put some more in. Let's put some more in. Give it a good stir. Let's leave it for a bit and you'll find that after a moment that will go blue. Okay. So you're going to try this at home? Yes? Tell me afterwards, okay. So, the colour changed because the cabbage water is sensitive to acid. And the fizzing was a chemical reaction between the acid and the bicarbonate of soda. We made a gas called carbon dioxide. We can have some more fun with carbon dioxide. I'll show you how. Do you know those tablets that fizz when you put them in a glass of water? Yeah? In this tablet, we've got some bicarbonate of soda, the same stuff as we've got here, and we've got a dry white acid powder, and a bit of aspirin to make us feel better. But the acid powder and the bicarbonate of soda don't react because they're dry. But when they dissolve in the water, the same thing happens as happened there. And we get bubbles of a gas called carbon dioxide. Paying attention. Good. Now, that's okay, you've seen that happen before, but let's have some fun with it. We talked about pressure earlier, didn't we? Well, I've got some of these plastic containers with snap-on lids, and I've put some water in there, because I reckon if I put one of those tablets into the water and it starts fizzing, when I put the lid on, the carbon dioxide produced won't be able to escape and the pressure will increase. And the pressure will increase, and the pressure will increase until the top comes off. That would be cool, wouldn't it? Yeah. Now, I would actually like some people to help me with this. Now, to help with this experiment, this involves explosions. You've got to be tough and brave, and not mind explosions. Okay? Are you tough and brave? Okay, I'm going to stand here. Okay. That's 1, 2, 3. Any more kids? 4, 5. Can you get out quickly? Okay. Make a line in front. Okay. Yes, go on. It's fine. How many you've got? 5, 6. Go and stand there. 7. Go and stand on this side. Over there. That's it. Go and stand by here. 8, 9, and 10. Okay. Just move back a little bit. Right, okay. Okay, make a line. So, here we go. So we need 1 container each. Can you pass those along? Oops, sorry, dropped it on the floor. Yeah, pass them. Yeah, one for you. If you can, just take the tops off. If you can't, I'll come and help you. Okay? 1 each. Okay. Okay. Now, I'm going to take the top off, and you hold the top in your other hand. Okay? I'll help you. Hold the top in your other hand. Don't spill the water, because they're half full of water, aren't they? You come a little bit further forwards. There's your top. Hold the top in your other hand. Hold the top in your other hand. That's good. Okay. Don't worry, it doesn't matter. Yeah. You've got yours off. No, there. Well, they've got to be really tight, so we get lots of pressure. We want lots of pressure, don't we? Well done. And make a nice straight line. Good. Where did I put the tablets? Over here. Now, can you all watch this little girl? You come forwards a little bit. Can you all look at this little girl? Can you all see her? If she holds it like that, the top could come off and hit her in the face. Well, we don't want that to happen, do we? So, can you all hold your tops out, your containers out as far as you can? Okay, good. Can you just step back a little bit so the girl behind you can see? Okay. So you're holding it out like this, like all the others. Hold it out. That's right, away from your face. That's good. And then the top's just going to go up and come down. That's boring. So what we're going to do, we're going to aim it at them. Okay?
Yeah!
And you get extra points if it gets grown up. Okay? So you tilt it forwards at 45 degrees for maximum range. Like that. Okay. Okay, is that good? Okay, you go and step back. Okay, I'll tell you what. Would you like to come and stand over this end with me? Or you just move along? We'll all move along a little bit. You come and stand in here. Move along that way. That way. That's it. Good, stand here. Very good. So, here we go. Get ready to pass me your top. Keep it pointing away from your face. Keep it pointing at the grown-ups. Okay? Don't aim it at me. Okay? Just have to wait for a little while before it goes. Hold it tight and just wait. Pass me the top. That's good. You can aim at anyone you like. You can aim at anyone you don't like. Pass me the top. Good. Point it that way. Try not to spill the water on the floor afterwards, okay? Point it that way. Don't spill the water in that way. Put the containers on the table. That's good. Hold it away from your face. Hold the end. Hold it. Okay. Point it. Don't point it that way. Up a bit. Up a bit.
This man's going to come tell you off.
Whoa! Hold it tight. That's it. Hold it tight like that. Give me yours. Hold it tight. You ready? Hold it tight. That's good. You ready? It's gonna go. Put them on the table behind you when they're empty. And I think we've got an unexploded one there. Put that on the table behind you as well. Whoa! Hold it tight. No, I can see that one's frothing. It's not going to work.
It's coming. It's definitely
Oh, it's not going to go. It's not going to go. Okay. Can you give him a clap? Go and sit down. Thank you very much indeed. Go on the table. We've got some unexploded bombs here. Be very careful. Okay, well done. Go and sit down. Thank you.
with my top.
Thank you. Okay. Now, how are we doing for time? Not too bad. When you go home, find some eggs, okay? You can show your parents something really, really interesting. Because an egg is a very, very strong shape. If you hold the egg this way, okay, between your fingers, you can squeeze it as hard as you can and you can't break it. Who's going to try that at home? Your parents are so pleased all the science you're learning today, okay? You really can't, honestly. Now, would you like to see something 6 times better than that?
Yeah!
How about 6 eggs? Now, 6 eggs should withstand 6 times more pressure. Right? Is anyone thinking what I'm thinking? Who said that? Right, good idea. You can actually stand on a box of raw eggs. And if you're really careful, they don't break. Sometimes they do. So it's not a demonstration, it's an experiment. Think of the difference. Because I've had some spectacular failures with it. But when you do this, you mustn't do it on the hard floor, because you can put all the force on one egg and it'll break and then the others will break. So when you do it at home, do it on an expensive carpet, okay? Right. So, unfortunately, I mean, we could have done it this morning, but unfortunately, I don't think there's probably anyone here brave enough to volunteer to stand on a box of eggs. We do have some volunteers. Now, sometimes I choose a wobbler. I choose somebody who does this, and then the eggs break. I'm looking for a gymnast or a violinist who can do that without wobbling. Is it going to be you? Is it going to be you? Yeah? Would you like to come out? Okay. Would you mind just slipping your shoes off? If you get eggy socks, okay, I'll apologise. Okay? That's the best I can do, I'm afraid. Right, so let me see you stand on one leg. Okay, you can stand on that leg. Very good. So, put your foot down again. I just want to see which leg you want to stand on. The floor's a little bit hard here. Come back a little bit. Back there. We'll put this soft pad down, and we'll put the eggs on the soft pad, and we'll put this soft foam pad on top of the eggs. I'll come on this side of you. Now, just step further forwards like this. Further forwards. You're going to put one foot on the eggs. Watch me. Just watch me first. And you're going to do that. And spread your arms out and balance. Okay? Okay. Get right in the middle. Right in the middle. Go on, go for it. Balance. Spread your arms. I want to let go. Get balance. Get balance. Yeah! Now, did you feel a sort of crunchy feeling? That's bad news. Let's have a little look. Hang on. Let's look. They've not broken. Now, wait a minute. Wait. Don't just trust me. This is science. I could have faked this, couldn't I? These could be fake eggs or boiled eggs. How do we prove that they're real raw eggs? You're going to crack them. I'm not going to crack them all. I'm just going to ask my volunteer to choose one of them. I've chosen that one. And we've not met before, have we? Okay. Just step back a little bit there so people can see. Let's break the egg. Yes, very right. Round of applause. Take the spoon. Thank you. Right. What should we do now? Oh, yes. Now, I like inventing things. And there's a need for an invention that stops you from spilling drinks. Do you know what it's like, kids, when you're told to carry a glass of water across the room, and by the time you get to the other side, you've spilt it? Yeah? I've worked out a way of making that impossible to happen. And what it is, it's a big piece of plastic with 4 strings tied to it. And if I put the drink on this, okay, it's rather wonderful because it doesn't spill. Okay? I told you it was dangerous on the front row, didn't I? Yeah? Okay? How about that? Now, I actually had a few glasses of wine to drink at a party last time I demonstrated this. And rather foolishly, and really stupidly actually, I just grabbed someone's glass of wine and put it on here and whirled it round, and it flew off and smashed against the wall. So experiments really are experiments. They're not just... do you think I could whirl it right round? You see, some people think there are magnets there. There aren't. It's just water standing on the plastic tray. 1, 2, 3, and around we go. Who's going to try that to come? I did think about trying it with an egg actually, but after the experience of the wine glass, I'm not going to. Okay, some of us earlier were having our noses tested. Who hasn't helped me with an experiment yet? Somebody who hasn't helped me yet. Okay, would you like to come out? And somebody else who hasn't helped me with an experiment yet. Who hasn't helped me? Okay, yes, would you like to come out as well? Okay, come and stand. You stand here side by side. Okay, that's very good. Stand side by side and face me. Good, that's brilliant. So you stand there. So to test your nose, we're going to make a circuit using your skin, like this. I've made a circuit by touching these 2 contacts. A tiny electric current is flowing through my skin. Okay, let's see if it flows through your skin. Hold the end. Will it flash if you just hold the end? No, because we don't have a circuit. Let's touch our nose and we have a circuit. Okay, let's test your nose. Test my nose. No, holding that with the other hand. Yeah, I know that. Okay, let's make it more interesting. You come and stand over here. Okay, you hold this and hold it as high as you can up in the air. Hold it really high. Okay. Now, I'm going to hold your hand. Now, would you touch the little girl's nose? Yeah! There you go. Okay, give them a clap, go and sit down. Thank you very much indeed. This is a toy you can buy. It's called Sensor Stick. Sensor Stick. Just Google that. Quite hard to find, I believe, but really, really good toy. Now, let's do another kind of electrical experiment with a balloon. You know the thing where you rub a balloon on your hair? I need someone with long hair. Okay, that'll be you. Okay. Can you stand there with your back to me? With your back to me. Okay, let's see if this works. It's working pretty well. Can you see your hair standing up? Yeah? Oh, look at that. So your hair, sometimes an electric charge can actually attract things. But I'm also noticing that the hair is actually being repelled. It's pushing away. The separate hairs are pushing away from each other. So electric charges can attract, but they can also push away. Right, now stay there. I'm going to need you again. Just go and stand over there a minute. Okay, stand there. What are we going to do? Let's try this one first. This is a piece of plastic which has got very, very fine aluminium powder in it. It's very, very, very light plastic, but it also conducts electricity. Turn your back to me again. I want to charge up, okay? Okay, now I'm going to drop this onto the balloon so it picks up the same charge as the balloon. Turn around so you can watch. How cool is that? That's real Harry Potter stuff, isn't it? Okay? And it's actually attracted to my finger. And if it touches my finger, it loses its charge until it touches the balloon again. And then I have to charge again. Oh, they're different patterns this time. Isn't that lovely? Now, finding this special plastic is quite difficult, okay? It's not easy to get hold of. But you can actually do something like this. Who's got a dog? You can do something like this with a poo bag. Okay? Now, it's tricky and it doesn't always work, so bear with me, but I'm going to try. I still need you for charging up, so just wait there. Okay. Let's put that in there. Now, to do experiments with static electricity, everything has to be really dry. So I kept this in the plastic bag. What this is, it's a piece of very, very thin poo bag, a rectangle, and I've got 3 slits in it. Can you see the shape I've made? Yeah? Okay, now I'm going to try and charge it up by rubbing it with my woolen scarf. I can't rub your head on it, unfortunately, when it's on the table. It's not going to work. So I've got the poo bag on the table. I'm going to rub it with my woolen scarf. Let's see if I can get it charged. This doesn't always work. It seems to be sticking to the table, so it's looking good. Okay, now I'm going to charge the balloon up on your hair. Turn around. Turn around. Okay, turn around so you can see. I'm going to throw this up in the air, and that's a poo bag. It's quite tricky to do this, but experiment at home, okay? Who's going to try that at home? Yes! Okay, go and sit down. Thank you very much. Round of applause for that. Thank you. Actually, there's one thing I forgot to show you. I can show you something quite funny. It's like something out of a horror film. Wait a minute, watch this. Let's just charge this up again, see if I can do it. Yeah, no, it's a bit scary, this. There's a really horrible horror film called Alien. Have you seen that? Yeah, it's not very nice. I don't like films like that. I'm going to charge up the balloon. Come here again. Come here again. It's so much better with your hair. Okay, let's get this hovering. See, it's pulling it away from itself. Now it's hovering. Now it's attracted to my finger. Okay, but the thing is, it's also attracted to my face. Look at this. Ah! Oh! Thank you. Go and sit down. Oh dear. Very silly. Yes, we've been noticing the balloon flying here. Obviously, there's a fan keeping it up in the air. keeping the balloon up, that's easy. The air is blowing it up, isn't it? But the strange thing is the way it stays in the airstream when you push it sideways. Really, really surprising and interesting. And if I tilt the fan, look what happens.
It goes higher.
It's gone higher, that's interesting, that it has. But it's also staying there to one side. See how far it's flying like an aeroplane. The air is flowing over the top surface of the balloon, being deflected downwards and making it fly like an aeroplane. Look at that. It'll drop off in a minute, but that's pretty amazing, isn't it? Now it's gone. Okay, you can try that at home with a hairdryer and a table tennis ball, okay? Or if you can get a really lightweight polystyrene ball from a craft shop, bend a drinking straw, and you can do this. Who's going to try that afterwards? Okay, very good. Okay, thank you. I like some toys have some wonderful sciencey sort of principles to make you think. This is my balloon helicopter. Now the air from this balloon blows through a whistle here. Now if the air blows that way, which way is the propeller going to go? The air blows that way, propeller goes that way. It'll spin round. Actually, come to think of it, I can demonstrate that very quickly with a couple of drinking straws. I forgot to get this one ready. Give me a pair of scissors. Just cut those off. Take two drinking straws, you have to join them together. You join them together like this. Push one end inside the other. Bend that to a right angle. Bend this to a right angle. Can you very quickly come here? Very quickly. Yes, quickly. Just stand here. Put your hands down by your sides. Position your mouth. And blow hard. Don't squeeze it. Just hold it very lightly in your lips. Blow hard. There, you can keep that. There we are. Round of applause. Okay. So here's my balloon helicopter. Let's try it. I wonder how high it'll go. So the air will go through the propellers, blow out through these angled nozzles, make it spin, and that was good. Oh, landed on you. Sorry about that. Now let me show you something similar. Do you ever go to parties where the grown-ups are talking about boring things? It's a terrible problem. I've got the answer. The answer is the rocket balloon. Okay? You keep some of these in your pocket, and when the grown-ups start talking about boring things, you make them fly around the room, and all the grown-ups stop talking about boring things. Squeeze a drinking straw in the end to keep it open while I blow it. You'll see why in a minute. Because the neck of the balloon is sort of soft and waffly, a bit like those whoopee cushions that make a very rude noise when you sit on them. Yeah? So when I let go, the air's going to go that way. Which way is the rocket balloon going to go? Oh! I don't know which way it's going to go. Let's try another one. You like that, didn't you? Which way is this one going to go? Pull the straw out. Excellent. Now, would you like to see a bigger rocket? Yeah. Right, now this is where we need to evacuate part of the audience. Maybe some of the chairs back there. They'll still get wet, but stick in the chairs. Now, just you children, you move right back. Right back, and you must stay sitting down. This rocket is going to go past you at 100 miles an hour. Can you hold him? Can you hold him? Okay. Here's the rocket. It's actually just a bottle. It's just a plastic bottle And I've got a special, you can buy this as a kit, and I've got a special rubber, soft rubber nozzle on here, into which I push the end from my air pump. But let's just get this set up. I'm going to use this bucket of water as a heavy weight to anchor it. And here's my air pump. So I'm going to push the brass end of the air pump into the soft rubber nozzle until it clicks in. I'm going to pump air in until the pressure increases enough to blow it out. Well, it'll blow out at about the same pressure that you have in your car tyres. That's a very high pressure. And it makes a bit of a bang, the air shoots out, the air goes that way. Which way does the bottle go? That way. It goes quite fast. Okay. Well, let's just see. So, let's connect this on here. I'm doing fine. I'm going to clip this onto this carabiner clip here. Move this back. What's happened to me? Microphone. Okay. Move this back into the little nice and tight. There we go. Oh, that's looking good. See the men on the sound desk? Did they look nervous? Okay, so we're going to pump air in, makes a bit of a bang when the stopper comes out, and hopefully the bottle will go the other way. Okay, here we go. Okay, now that was reasonably interesting, but I would like it to go much, much faster. And there's a way of doing that. Let's just do a thought experiment. You're standing on the I'm standing on a skateboard, okay? I'm standing on the skateboard, facing that way. If I stood on the skateboard, I'd fall off, but never mind, imagine I was. And I'm holding a balloon. And I throw a balloon full of air off the back of the skateboard. Is the skateboard going to move? Imagine I'm standing on the skateboard, holding a heavy bucket of water. And I throw a heavy, I'm not going to do it. I throw a heavy bucket of water off the back of the skateboard, okay? Now is the skateboard going to move? Yes, because the water is heavier, okay? Right, so, let's put some water in here. Yeah, and shoot some water out the back. Yeah, so you're thinking, well, I'm thinking. A bit more. Yeah. You are going to get so wet.
Oh, yes. Ready?
Okay. Now we better just put a little bit in, because we don't want this boy here to get wet, do we? I'm sorry.
So, Kim, so.
I think that's enough. I think that's enough. You're very, very keen scientists today, aren't you? You really want to see what's going to happen. I think that's actually quite a lot. I got a bit carried away there. Never mind. Normally, these things are made to be played with outdoors. If you Google Rokit, R-O-K-I-T, Google that, you can buy this kit, and you can shoot it into the sky in the park. But you need a really big park, otherwise it won't land in the park. I've measured the speed that this travels at using video and analysing the frames, the video frames, and it travels at 100 miles an hour. So when this rocket hits the top of the pole there, next to the Sandman, okay, it'll be travelling at 100 miles an hour, and when it hits that, you will all still be looking here. Okay, I've got lots of photographs to prove that. So, let's just clip this. The front of the bottle up a little bit with this bottle, this glass. That's better. It usually goes after about 7 pumps. Okay, so we'll count the pumps. You children must stay sitting down. If you just go for a little walk and stand here, he could hit you at 100 miles an hour. Not good. Okay, are we ready? We're going to count the strokes. After about 7, I think it's going to go. And when it hits the top of the post, you'll all be looking here. 1, 2, 3, 4, 5, 6, 7. Okay. All right. Right. I hope you didn't blink when that went up. We've got a wet floor here now. Okay. So let's just summarise what we've learned. We've learned that children are less boring than grown-ups, and that makes them better scientists. We've learned that children are better at noticing things. Okay? You're more curious. You think about things. Okay? This is really, really good. And this makes you better scientists than grown-ups. There's just one more, and if you try some of these experiments at home, try any of these safely, especially with that water rocket, and there's one experiment you must not try at home, because we haven't done it yet. It's burning custard. Now, custard powder absorbs water vapour from the air, and it causes those little grains to stick together, which is not good. We want them to be separate, so the oxygen in the air can get round each separate grain. So I've actually taken the same custard powder, and yesterday I dried it in my oven. Okay? If I take the top off, you'll see the dust come out. You see, it's really, really dry custard powder. You always have to keep your powder dry, as they say. So I'll just put a little in. I do this in schools sometimes. I go around schools doing this show sometimes. And I say to the children, I say, you don't want me to blow your school up, do you? And they all say, yes. Okay. Let's just put a bit more in. And get plenty in. Okay. Bit more? Now, a little bit at the front to keep it nervous, she's not sure. A bit more? Yeah. It's all right, you're at the back row, you're okay. Now, the people at the front, and even further back, you will actually feel the heat on your faces from this explosion. Okay, you'll feel the heat on your face. And what you're experiencing is the energy in just a couple of spoonfuls of custard. Okay, the dieting magazines talk about calories, don't they? Yeah? And calories are a measure of energy. And energy, basically, is a measure of how much heat you're going to feel on your faces when this burns. Right. One more? Yeah. Did you say no? Yeah. That's all. What that? Oh, let's go. That'll do. Okay. Right.
Don't open your mouth.
I'm going over here. Goodbye. 10,
9, 8, 7, 6, 5, 4, 3, 2, 1.
Okay. Bye-bye, everyone. Thank you very much. Bye-bye. Before you go, Every child has to have one of these to annoy your parents with on the way home. You've got to annoy your parents scientifically. It's a drinking straw. I've flattened the end and cut it to a point. Blow hard, blow hard. Don't choose the colour.